Can you believe it, that a seemingly ordinary rock like this could contain the power to destroy the world? Particles collide, split, and then instantly explode. That's right, this is an atomic bomb. In just a very short time, it can leave an entire city in utter ruins, causing tens of thousands of injuries and deaths. Its power is so immense that Oppenheimer, the father of the atomic bomb, was moved to say this after its successful test detonation. "Now I am become death, the destroyer of worlds." So, can the atomic bomb really destroy the world? In the rest of this video, we will attempt to answer that question. But first, we need to truly understand the power of an atomic bomb. This atomic bomb is about 3 meters long and 0.7 meters wide, smaller than a small car. But it packs the power of 20,000 tons of conventional explosives, a yield of 20 kilotons. And now it begins to detonate at an altitude of about 500 meters above the ground. A light suddenly appears in the sky, brighter than 1,000 suns, piercing through the pupils of shocked onlookers, searing their retinas instantly. Heat follows immediately, with temperatures of thousands of degrees Celsius that can vaporize steel, plunging the city into a sea of fire, while carbon-based life forms are reduced to nothing but shadow-like footprints. But all of this accounts for only 1/3 of the bomb's power. Next, the fireball at the epicenter expands outward, violently compressing the surrounding air to create a shockwave. It spreads in all directions at supersonic speeds, crushing everything to pieces before anyone can even hear the massive blast. As the fireball cools, a mushroom cloud tens of thousands of meters high soars into the sky, piercing the heavens. And it's still not over. Besides light and heat, a nuclear explosion also produces an extremely lethal form of energy: nuclear radiation. These invisible high-energy particles and rays can kill cells, causing nausea and vomiting in milder cases, and certain death in severe cases. Even after the blast, the nuclear radiation doesn't disappear right away. The residual radioactive particles in the cloud fall back to the ground as black rain, continuing to contaminate the land. Even if you are lucky enough to escape unharmed, sheltered in a basement or other bunker, when you emerge from that shelter, the horrific scene before you will inflict permanent psychological trauma. So, what exactly gives the atomic bomb such immense power? The answer lies within its name: the atom. However, the unleashing of this deadly power was built upon the discoveries of countless geniuses. Let's travel back to 1938 when our first genius appears, the German chemist Otto Hahn. While bombarding the nucleus of a uranium atom with neutrons, he discovered that it surprisingly split apart, forming two new nuclei inspired by cell division. This process was named nuclear fission. And nuclear fission didn't just create new elements, it also released. The physicist Lisa Meitner calculated and discovered that this energy and the mass lost after nuclear fission perfectly aligned with the principles of Einstein's mass-energy equivalence equation. Energy that had previously only existed in theory thus became a reality. But a single fission event wasn't enough until the Joliot-Curies, Fermi, and others discovered that at the same time as nuclear fission, there was also the production of 2 to 3 neutrons. These secondary neutrons could continue to induce nuclear fission, allowing the reaction to proceed automatically, becoming a chain reaction. This meant that if there was enough material, an unimaginable amount of energy could be produced. With that, the final piece of the theoretical puzzle for developing atomic energy was put into place. However, at that time, the world was shrouded in the shadow of war. To prevent Nazi Germany from using these discoveries to create a new type of weapon, physicists Leo Szilard and others, together with Albert Einstein, wrote a letter to U.S. President Roosevelt, hoping they would take the lead in initiating related work. And it was this very letter that kicked off America's atomic bomb research, which would later develop into the world-renowned Manhattan Project. And so, numerous geniuses gathered in the United States, all to develop the atomic bomb. before Nazi Germany could. However, even for the most brilliant minds in the world, it was not easy to turn such a cutting-edge theory into a reality in such a short period of time. In a chain reaction, if after each fission event, the number of remaining neutrons is exactly equal to 1, the reaction will proceed in a stable manner, reaching a so-called critical state. The amount of nuclear material required at this point is called the critical mass. An explosion can only be triggered if the mass is greater than this critical mass. In 1942, physicist Enrico Fermi successfully achieved humanity's first self-sustaining chain reaction. The material used was the element uranium-235, with a relative atomic mass of 235. However, as the only element in nature that can easily undergo nuclear fission, the proportion of uranium-235 in uranium ore is only 0.72%. Therefore, for the critical state that originally only required 260 grams of pure uranium-235, the actual experiment used a full 52 tons of nuclear fuel. Clearly, a volume like this could not meet the requirements for a weapon. To make an atomic bomb, the purity of uranium-235 had to reach over 90%. For this purpose, the Manhattan Project built two dedicated uranium enrichment plants. One of them used 15,000 tons of pure silver to make the electrical conductors, while the other one's electricity consumption alone was equivalent to that of the entire city of New York. Finally, after spending over $2 billion and mobilizing more than 600,000 people, the Manhattan Project successfully built 3 atomic bombs. One of them was named Little Boy. On August 6, 1945, over Hiroshima, Japan, it was detonated. It was a gun-type atomic bomb. Upon detonation, explosives fire one small piece of nuclear material into another, causing the combined whole to reach critical mass and trigger a nuclear explosion. Its design is very simple, but the efficiency of the nuclear material is low, at only 1.2%. 3 days later, the Fat Man atomic bomb dropped on Nagasaki, Japan, utilized a different, implosion-type design. It uses explosives on the outer layer to create an inwardly focused shockwave, compressing the nuclear material and increasing its density, thereby allowing it to rapidly achieve critical mass and trigger the explosion. Although this structure is relatively complex, its nuclear material reacts far more completely with an efficiency rate as high as 20%. And just like that, the atomic bomb was officially born. With it, human history entered a new age. But faced with this new age, as Oppenheimer said, a few people laughed, a few people cried, and most people were silent. What kind of age is this? Really, will it be destroyed at the hands of the atomic bomb? Actually, from a certain point of view, it won't be. About 66 million years ago, an asteroid struck the Earth, causing the extinction of the era's dominant species, the dinosaurs. But even so, the Earth continued to spin as usual, and life has still continued on to this day, and including the hydrogen bomb, an enhanced version of the atomic bomb. Humanity possesses a total of about 12,000 nuclear warheads. Even if you were to combine them all into a single superbomb, the energy released from its explosion would be less than 1/10,000th of the energy from that asteroid impact. For a planet that has endured for 4.6 billion years, it is truly quite insignificant. But despite this, for ordinary people, the atomic bomb remains terrifying enough. It can easily destroy an entire city and indiscriminately kill every single person within its target area. Its cost is so immense that after decades of an arms race, the US and the Soviet Union came to the conclusion that there are no winners in a nuclear war. And so, to a certain extent, nuclear bombs have actually created a delicate balance. Even at the peak of the Cold War, peace was still maintained. In 1961, the United States took the lead by deploying, in places like Turkey, a large number of missiles armed with nuclear warheads. with a range that reached the Soviet capital of Moscow. In retaliation, the following year the Soviet Union secretly deployed nuclear missiles in Cuba. This made the United States feel severely threatened. In October of that year, the U.S. announced a military blockade of Cuba, and war was on the brink of breaking out. This was the famous Cuban Missile Crisis, and just as tensions reached their peak, a letter from Khrushchev was delivered to the White House. The letter was filled with a powerful sentiment of wanting to avoid nuclear war. 2 days later, the two sides reached an agreement. The Soviet Union announced it would withdraw its missiles from Cuba, and the crisis was resolved. In reality, crises like this have occurred many times throughout history. The newly founded nation of China was no exception, facing repeated threats during the Korean War. Facing defeat, the United States tried to threaten the volunteer army with atomic bombs to force them to withdraw from the battlefield. During the 1958 Taiwan Strait crisis, the United States once again brandished the threat of atomic weapons to stop China from unifying with Taiwan. Even the Soviet Union, once considered our big brother, also made threats during the 1969 Sino-Soviet border conflict, proposing the use of atomic bombs as a key means of attacking China. However, crises like these rarely happen anymore. But they didn't just vanish into thin air. It's because China successfully developed its own atomic bomb. Today, we no longer have to worry about whether the atomic bomb can destroy the world. At least, it won't be allowed to destroy your world.